So you guys know about vectors and all? What is a vector? Mathematics have you studied vectors? Atishwadi, right? And practice. Like practice or not? Good question. Even practice. I'm sorry, I'm not able to do so. I have to wait. Okay, yeah. Sure. Yes. Light. What do you know about light? Anyone? Light. What is light? Yes. Yeah. And okay. Any property of any other property of light? Good. Anything, Atish? You burn a lot of crackers. So light will be coming out of it. Come on. Yes, Atish. No, no property. Okay. Just repeat what she said. What is light? Whatever she said. What is light? She said something about light. No? Yeah. Before that, she said something. Light the what? Crackers. Okay. So this is what we are going to study. What happened? Something funny? Tell me the joke. I will also laugh with you guys. Crackers what? Food. Oh, is it? Good, good. It's fine. Oh, that's cool. Okay. Let him laugh. Okay. Let's study a little bit. Okay, you guys have done the assignment and all. So you have some doubts in assignment. Let's first discuss few topics. Okay. I just want to know how much you have studied. Okay. Then we'll start solving problems. Okay. Just give me a moment. I'm sorry. Really sorry. So light in our life, right? So light is a form of energy that we can convert into another form of energy using some devices, right? So those also we'll be studying later. So these light travel in a straight path. Anything else that you know about light? Light travel, can it travel anywhere else? It can travel in any medium. Okay. So it depends. What is the speed of light in vacuum? What? Meter per second. Fine. So this is how much we assume. It's actually 29774 something. So approximately this much we assume that this is the speed of light, and it is represented by the letter. Anyone? Yeah, you know that. Come on. You know, right? Any letter among these? Okay. So that's how we represent the speed of light. Okay. It's fine. You can write anything, but in your book generally it is written c is equal to 3 into 10. That's how much we assume the speed of light is. Okay, light obviously we have learned that it travel in straight line. So you have learned about mirrors and lenses, everything you have finished. In your school you have finished these topics. Okay, very good. So so shall we directly go there, or do you want some discussion on light, the properties of light? We shall skip those, right? So what do you know about plane mirror? Let's start from mirror, plane mirror. Okay. What is plane mirror? Straight like me? Is it? Okay. So is this a mirror? No. Why? Suppose this is a glass. So is this a mirror? No. Why? Because it should be having a polish. Uh, must be having polish, right? One side. So which side do you want to polish? Any side. It doesn't matter, right? So this is a mirror, right? Okay. Now he's standing here. Who is this? Cracker. What? Not you. I said Cracker. So Cracker is standing here. So will he be able to see himself? Yeah. Yes or no? Why? You tell me. Will he be able to face? Right? You got it? That means you're standing in the wrong. You have mirror in your room, right? So if you stand the opposite side, the painted side. See, if you take down your mirror, you'll see one side is painted. This is the painted side. Okay, some orange paint will be there, and inside that there will be a silver coating, right? So this surface we call the shining surface or the polished surface, anything you can say, through which the reflection take place. Okay, so you won't be able to. Yeah, definitely there will be some image will form, but you won't be able to see it, right? And how it will form. So we will study about that later. It sounds stupid, really stupid, that how can image form when we are standing on the opposite side of the mirror, right? We'll see about that also. In most of the books, it is not discussed, okay, because it's not the area of interest. People don't usually understand what is going on here. So we'll see this later, not now. Okay. So that means the definition of this plane mirror is clear. You guys know what a plane mirror is. You want some? You are here, right? What happened? You're in some different dimension. You're okay, right? All good. What's your name again? Atish. Stop laughing. So now I'll draw this horizontal mirror. Okay. This is the painted side. Okay, that means this is the shiny surface or the polished surface, what we use to say. Do you guys know about the terminologies related to a mirror? Incident ray, reflected ray, incident angle, normal. These things you know? Okay. So we'll just, can anyone tell me the first law of reflection? See, when we are, wait. When we are talking about mirrors, we are studying actually reflection. First, let's go through the fundamental. Complete 100%. Right now, we are studying about reflection. Reflection through mirror. Later, we'll study refraction. Then we'll see that how refraction and reflection both take place simultaneously. Okay, that is the last part. Got it? Okay. So, what is this? It's a normal, right? What is first law of reflection? Same plane, right? What is Plane. What is same plane? Can anyone explain? Plane. What is a plane? When we say that the incident ray, the reflected ray, and the normal all lies in the same plane. What is that plane? I want to know that because most of the guys you get confused there. Okay. Same. Yeah, yeah, you're right. You're right. Just say yeah. Same surface, right? Like suppose this is your x, that is your y. The same thing I was explaining to your Julius. You know this thing, right? X and y coordinate system, rectangular coordinate system. Also, we call it a Cartesian coordinate system, right? This is there in your mathematics book, and everywhere you must have known this. So let's assume this line, this is your y, and this corner is your x, that one. So this is a plane, xy plane. This is your xy plane. This whole wall is your xy plane right now, because that vertical line beside is that corner. See that corner? This edge, this one. Don't tell your teachers I marked here. Otherwise, they will throw me out. So this is what this is y, and that is your this is your x. Okay, and this whole board, this whole wall is your xy plane. Something you want to go out? So xy plane. This is called xy plane. So if I lit a torch here, okay, suppose a laser light on this plane. So what we are saying, the reflected ray, sorry, the incident ray, the reflected ray, and the normal all lies on the same plane. Okay, on this board only. Literally how I'm drawing it. Okay, it's literally. You know the meaning of word literally, right? It's as it is, what I'm saying. So if this is a mirror, okay, this is a normal. This is your incident ray. So this is a wrong method to draw. What we'll do first, yeah, XY plane is clear, right? XY plane is clear, right? Okay. So this is your X. If in the coordinate system, if you'll see this mirror is kept like this, right? Like this. The mirror is kept like this. Okay, and this is the shining surface. So this is your incident ray. Okay. Now wherever the incident ray touches this plane, this reflecting plane. Okay, surface of reflection. This is called, right? You guys know that terminology, right? That's what you said me. I'm not discussing that. So there, at that point, you will draw the normal. N and dash. It's just the reference. You can write any name. P also you can write. It doesn't matter. Okay, and this is your reflected ray. Okay, so the first law says that this, and this line, all these three lines are on the same plane, like I have drawn it here. So if this is a mirror, okay, and if I put a laser light here, in the experiments you will see in your school, right? So if I put a laser light here, so it will travel in a straight, light also travel in a straight path, right? So it will hit here and it will reflect like this on this same line. Okay, got it? So it will come like this and it will go like this. So that's what that was the first law of reflection. The second law of reflection is, and which is angle of incidence. So this is the normal and this is the incident ray. So incident ray, I'll write IR, incident ray. So this is your angle of incidence. I'll write like this. Is that clear, Atish? And angle of reflection. So reflected ray. Is that fine? No issues here till now. So this is R, angle R. So the second law, so angle I should be equal to angle R. See, this is always true. Even if we take the spherical mirror, and in that also it is true. That angle I will always be equal to angle R. So don't worry if the mirror is curved. Definitely you may have different, curvatures, but still it will follow this relation. Okay, so till this far, you guys know each and everything. Shall we solve one problem? Okay. What do you know about real and virtual image? Real and virtual. Can you differentiate between real and virtual images? So tell me some differences. Real image can be observed on a screen. Okay. It can be obtained on a screen. Okay, correct. Anything else? It's in front of the mirror. Okay. Anything else? Behind the mirror. You tell me any one difference. Difference between real and virtual image. And he repeated. Smart, huh? Good. Okay, so that means you guys know few differences between that. We are not going to cover the theory because we don't have a lot of time. Let's start with the numerical. You know about spherical mirrors? How do we form images? Can you do that? You know everything about the terminologies related to spherical mirror? Atish, you are having problem. Okay, so let's see few definitions about spherical mirror first. Atish, okay, do one problem. You have a plane mirror. Okay. Okay, one more thing I forgot in plane mirror. This is okay. This is N, this is reflected ray. What is emergent angle? Angle of emergent. Okay, correct. Okay. Again, let's not discuss it here. I don't think it is necessary here. We'll discuss it later. Okay. Let's discuss about this first plane mirror. We'll discuss about spherical mirrors. Bad handwriting, I know. I know. Why I have drawn this? What is this? X and Y, right? Whenever I draw like this, everyone will be X and Y, X and Y, X and Y. Yeah, it is X and Y. Why I'm drawing this? Okay, we'll see. Suppose this is what a sphere. That's what we are learning, no? Spherical mirror. Sphere, can you give me example of a sphere? Globe, okay. Earth, okay. Earth is, what's the shape of Earth? It's called in geography. Okay, the shape is called geoid. Okay. Not studying even geography. Okay. This is a sphere. Give me a very simple example of sphere. Cricket ball, football, or right? So suppose it's that. Okay, and it is silver. It is made of glass. Okay. The sphere is made of glass. What we did, we cut it from here. We use the diamond and we cut it from here. And suppose the outer part is the reflecting part, polished surface. Okay, that means it will reflect. Okay, fine. So this, so what type of mirror is this? Yeah, concave or convex? Concave. Which side is this? Polished side. That means the reflecting side is which side? Which side is the reflecting side? This side is reflecting or this side is reflecting? This side is reflecting? Is it? See, I don't know how it is given in the book. I have to check that. Okay. But anyway, it's fine. If we are saying, okay, this is the reflecting surface, if this is the reflecting surface, if this is a reflecting surface, which type of mirror is this? Concave, right? And suppose what type of mirror is this? If this is the reflecting surface, RS means here reflecting surface. I'm not writing everything. So this will be a convex, right? It is a convex hump shape, right? So it is a convex mirror. concave. Okay, so you take a glass sphere and you cut it. But anyway, when we are studying in our notebook, so every time we'll be putting it like this. Suppose it's a sphere, it was cut like this, so we'll put it like that. I think you're not able to understand it. Like this. Okay. The sphere is in all directions, right? We'll be studying only the two dimensions. Okay, like the plane mirror, we kept it like this, isn't it? Or like this. So similarly, we'll be putting the spherical mirror like this. All right. Any issues there so far? I don't think so, right? And this x, this line x, this is called your principal axis. Okay, that's why I have drawn this x, so that it will be easier to understand. What is this point called? This point. Now, okay. Now you understood how to make a that is a pole, right? That the point is called pole. Okay. Okay. So we know, right? So far we know spherical in spherical mirror pole we know. Now we know the principal axis. Principal axis. What else? Focus is there, right? What is focus? Now shall I rub it? I'll draw one mirror on it. Whether it is a concave, convex, it doesn't matter. They have different properties, but okay. What mirror is this? Atish, concave mirror. So what is this? Principal axis. Okay, and this is your pole. So the line passing through the pole is called your principal axis. Okay, and it's not a fixed point. For a particular mirror, it is a fixed point, but we can vary it. Okay, we can also draw like this. Okay, so this line is also passing through pole as well as pole. So is it a principal axis or not? Why? Yes, it has to pass through the focus and. So what is center of curvature? Yeah, the center of the sphere. Right? So this was the sphere from which we cut it out, and this was the center. So that is called a center of curvature. See, the mirror is bent in this direction. So of course, it's this part of the circle, right? So it will somewhere the center of curvature C will be there. Okay. You tell me, Atish, what is radius of curvature? Radius of curvature. No, radius of curvature. What is radius? You see the sphere? This is center of the sphere, right? What is the radius? Any line I can draw anywhere, this is radius. Fine. Even if I draw it here, this is radius. Okay. So what is the that means to the from the surface to the from the center to the surface, that distance is called the radius, right? So this is the center, and this is the surface. So this distance is your radius of curvature. This distance from P to C is called your R. That is radius of curvature. Even is this radius of curvature or not? Yes or no? C is the same sphere. So this length is also same, right? So if this is, suppose, let's say this is point A. So from C to A, that is also R. This length is also same as that this much. Okay, you must know this. Okay. Suppose, and what is focus? Okay, Atish, you are understanding or not? Why the focus is here? Anyone? Yeah, it's written in the book. What's the main reason? Yeah. Yes, you tell me. Okay. See, what you said is correct. See, when you have an object kept at infinity, very far away from. See, infinity doesn't mean it has to come from sun or from stars. Okay, if the length is too high, Okay, 100 times higher than the radius of curvature. That time also we call it infinity. It's very high. Okay, so suppose when it is kept too far from this mirror, what will happen? The rays will come parallel to the principal axis from the object. Okay, and the rays coming parallel. So this is also parallel. Rays coming parallel. It will pass through. All will pass through a common point. All rays will pass through a common point, and that point is called focus. That's why this focus. And somehow it is half of the radius of curvature. Okay, there is a mathematics behind that. You will be studying that in, I suppose, in 11th standard. We can also do it here, but it's not required as of now. You just understand why it is passing through focus is the property of the circle. Okay, is the property of circle that when a light comes parallel to the principal axis, it will pass through the focus. All right, you're getting my point or not? What this? Tell me, yes or no? Yeah. Okay. Good. So these things, Atish, you are getting it or not? Why this is called focus? Focus, right? It passed all the parallel lines. Suppose if this is your parallel line coming, it will also pass through the focus. Okay, or it will also go through this point. And you guys know that if okay, let's do one problem. Rather than discussing, it's better to do a problem. Shall we do it from your book? Give me your book. Give me that book. Which which book is this? Your NCRT foundation course book is there, no? That MTG. Oh, chemistry. Uh, Master, can you give me a book from there? Just a minute. Yeah, book one book will be there. Just open it. Open it. Take out these two books. Let's standard, right? Let's do one problem. We'll do it from mirror. Okay. Like which question is this? This is a solved example so that we can also understand. You guys will do this. Okay, write down the question. An object is placed at a distance of 20 centimeter. You know mirror formula? You have studied mirror formula? What is mirror formula? 1 by 1 of you. 1 is equal to 1 by f. You tell. Correct? Correct? Diana? Correct? This is correct? What? Here it is plus. Yeah, this is correct. This is mirror. That is lens formula. Yes. Okay. Okay. See, this problem, a lot of things will be clear. That's why I'm starting from a problem. Okay. So you have some basic definition. What is U? What is V? What is F? First, tell me this. Okay. Focal length, object distance, image distance. Okay. Okay. Just write it. An object is placed at a distance of 20 centimeter from a concave mirror. Okay, from a concave mirror of focal length 15 centimeter. At what distance from the mirror should a screen be placed to get a sharp image? First, understand the question, then we'll start solving. Okay? So it's very important to understand the problem first rather than just start solving it. Why you are writing on the back side? You don't have a notebook for this? See, whenever there is a class, see, sometimes it may happen that instead of physics, there will be a chemistry class, or instead of chemistry, there will be a physics class. It depends upon the management. You do one thing. For my class, what you can do, you can have sheets, okay, and you can put it in a folder if you want it. because it's very hard to carry, all these books. So that you can carry. Yeah, if you can carry a notebook, that will be fine. I don't have any problem with it. I'm just giving you options. Okay. So everyone wrote the problem. Shall I repeat it once? An object is placed at a distance of 20 centimeter from a concave mirror of focal length 15 centimeter. Okay. At what distance from the mirror should a screen be placed to get the sharp image? See, it's a good. It's better to bring your books, okay, so that you don't have to write the problems. Okay, close that book. Close that. Yeah, close it. It's not from there. Let's understand this. Let's solve why you are closing it. Closing a notebook. I asked first. Okay. Can you solve this problem? First, read the problem. It says an object is placed at a distance of 20 centimeter. What is given? What is 20 centimeter? 1 by u is given. U is given, right? U is how much? Fine. Okay. And from a concave mirror. Now, concave mirror, right? Is this a concave mirror? Right? Okay, concave mirror it is given. These are the highlights. 20 centimeter, the object distance, concave mirror, focal length, right? F is also given how much? 15 centimeter. Okay. And what else? And see, at what distance from the mirror should a screen be placed? Why it is written screen is placed? What do you mean by that? Image. That means real image. Real image can be obtained on a screen. That's what you said in the beginning, right? So these are the details given. See, indirectly it is given in the book. That means what do you need to find out? V you have to find out, right? Now tell me how you will find it out. Can you do that? You have the formula. Can you do that? Do it fast. Let's see who gets the answer. Faster. We have class in what? 5? 5:50. 515. It's already 515. 60. 60. Okay, good. Centimeter. You must say the unit all the time. So you are saying the answer is 60 centimeter. Anyone else got this answer? Yes, sir. How much? Why you are hiding it? You don't need to. You can keep it here. Why you are hiding it? Oh, you will do the calculation with different pen, is it? You just need to do this. Show me where you got 60. How you got 60? So you are getting 0. Do it again. Show me yours, Diana. Where is your calculation? Here. Do it here, no? Don't pinch man in class. After class you can pinch each other. Keep pinching. I don't care. Done. Okay. Everyone got 60? Help him. Take the LCM. Oh, forgot. Okay. Sir, you got 60. So not don't write like this. So 1 by V is 1 by 60. No. So V will be 60. 60 not elephant centimeter, right? Now everyone got it? If I'll say all of you are wrong, then sign convention. You forgot the sign convention, right? Oh, okay, let's under. That's what my point was for this problem. Sign convention is very. How do you do the sign convention? In the beginning, I told you something, right? I showed you a coordinate system. This is x, this is y. Correct? You can put anything, it doesn't matter actually. I know in the book it is always x, this is y, right? You can put anything, it doesn't matter. But okay, let's follow this. This is positive, this is positive, this is negative, this is negative, right? Okay, and this is the origin, right? Oh, now what we will do here, So this is your principal axis. Fine. So this point is your origin. O, or in this case we write P for pole. You can write O, doesn't matter. This is your X. This is your Y. So you measure the vertical, horizontal distance this side and vertical distance in the upward direction. Where is the focal length? Which side is the mirror curved? This side, right? So this side, so your center of curvature will be this side. Focus will be this side. Fine. So all are negative only. If you keep your object here, will you be able to see it? No, because this is not the polished side. This is not the reflecting side, right? If I'm standing here in the beginning in the plane mirror we studied, no, we had a discussion that if we are standing this side, we won't be able to see it. So there is no need of calculation, isn't it? Sanjay? So that means the object is also in the left side. So left side is always what? Negative, and right side is positive. So everything is in the next left hand side, right? So we know that U is in the left hand side, so it will be negative. Focus, this will be negative, right? And then we will find V. We don't know. We don't know V because if it is, suppose the image is forming here, that will be positive. If you are getting V positive, suppose if you are getting V positive, that means it's a virtual image and it will be forming in the opposite side. Got it? So this side is positive, this side is positive, this is your negative X, and this is your negative Y. Okay, so whatever length you measure from downward, that will be negative, upward positive, left side negative, right side positive. Got it? Now do it. So every time, see in your problem, it won't be written negative 20 centimeter. It will just be written, it is kept in front of the mirror. Okay. Now you have to understand what is, and it may change in the case of lens. Okay. Now find V. Find V. So if okay, let's put it here. 1 by V will be equal to what? 1 by F minus 1 by U. Is that correct? 1 by F is how much? Minus 15. Any problem? Minus 1 by U. U is minus 20. So this you will get how much? So minus minus can I write, if it is multiplied, so can I write like this? Plus, if you take the LCM, okay, what it will be? 60. Okay, and this will be how much? Minus 4, 3. How much you are getting? Minus 1 by 60. So 1 by V you are getting. See, don't change V in the beginning. Don't put V as minus here. Because you are calculating V. You don't know the V. V where, if V is coming positive, that means it is a virtual image. If V is coming negative, that means it's a real image. But Sanjay, that's fine, right? Your name is Sanjay, no? Who cares? It's Sanjay from today. Okay. V is equal to minus 60 centimeter. Don't forget the unit. Okay. So this is minus 60. That means now shall we draw this here? So we got you got the calculation. So that means V we are getting how much? Minus 60 centimeter. This is our answer. So just put it in a box. Okay. Always put your final answer in a box. Just draw a box. Do it. Do it in your room. Now can anyone draw it here? Do you know how to find magnification? Lateral magnification. I'll just say magnification for now because I don't know if you have studied it or not. You have studied that as well. Okay, good. Okay, so what things are given? U was minus 20, F was minus 50 centimeter. F is how much? Here, and U is 20. So C is how much? 30. That means the object is kept between C and F. So let's say this is the object. Let's say this is the object and it is kept at, this is your U. Sorry. Excuse me. Is this fine? This is focus, huh? This is focus. I'll write it here. So that this is U. Because it is in the left side, that's why it is negative. Minus 20. U is your minus 20. Centimeter. All the units are in centimeter. Now focus is minus 15. This is minus 15. That's how you measure from this line. This is the origin, no? From this, don't measure it from here. Don't measure it from the curved surface. Okay, always we are measuring it from this vertical line. Okay, that is passing through the pole. All right. What are you dreaming? You are understanding or not? All clear as of now? Because we have to go very fast. From now onwards, we'll go very fast. Tomorrow, we'll finish the lens also. Okay. I just want to know how much you have idea. So these things we have to draw. So if the object is kept in between your focus and center of curvature, where the image will form? Where will the image form? Let's see where it forms. We have already got the answer, right? V is minus 60. Okay. Okay. So what will be the nature of image? Real and inverted, right? Okay. So we'll see this point, this head. We'll see this head. So it will go, let's draw a parallel line. That's how we do, right? And it will strike the mirror and it will follow the, okay, what law it will follow? Angle of reflection is equal to angle of incident. So normal is where? Like this. Normal will always pass through what? Center of curvature, no? You know this thing or not? Yes or no? Just don't say yes if you don't know it. Because, see, okay, I think you are not taught this thing. Any line that you draw from center of curvature to the spherical mirror, wherever there is incident, that is your normal. Okay, because from the property of circle, if you remember, this is normal, no? 90 degree. You know this? This is also 90. Same thing is happening there. Got it? So this is a spherical mirror. Okay, and we are drawing from the center this line. Okay, and see, this is your tangent. You have not studied these things. You know these things. Property of circle. You have to. Have you guys studied? How only you know this? You haven't said. Okay, once we'll discuss this also in next class. Okay, so that I thought you guys know this thing. So this is your angle of incidence I. Same will be the angle of reflection, not refracted, and it will pass through what? Focus, because it's a parallel line. No, parallel line will pass through what? Focus. So let's pass it through the focus. So this is what? Angle R. Angle I must be equal to angle R. Okay, now let's pass a line from focus. Okay, if we pass it from focus, what will happen? It will go parallel to the principal axis. It will go parallel to the. I know the drawing is not very clear, but try to understand this. Okay, and so this is the head, right? This point we are tracing the uppermost point. So wherever it intersects, there the formation of image will occur. You know these things. Do you or not? Yes or no? You don't know this thing. Okay. So why not telling you these things? This I think you have studied it, but you haven't studied. You haven't done your homework. Yeah, you should do it. It's not very tough. You can do it. So this is this point. If this is the head, the image of head is here, and we'll just make it like this, right? Inverted, real and inverted, and this is the distance of your what? Image. So this is how much? 60 we are getting, and it is in the left hand side, so it is negative 60. Is it clear? Yes or no? This thing is not clear to you and to you also. It is clear now, but we will discuss it again. Okay, because it's very important to understand what exactly this line, why I draw this I and R. Okay, it's very important because I'll be giving questions from here. I won't give questions these are very simple questions. So don't expect full If I'm making a paper, so you won't be getting problems like that. Okay. Okay, I'll just give you the give you the object. I'll give you the image and I'll ask you to draw the mirror. Can you do that? Mirror or lens, whatever it is. Okay, so we'll stop it here. And I think there are little slight homework that need to be done. Otherwise, I think you guys have done this part. Yeah, you want to ask something? If you want to ask any problem is there, till say in spherical mirror, if you have any problem, you can ask me. Okay, because the time is over and I think you have to go to your home as well. Everyone is hungry, no? You have to go to play. How many of you play dancing, any other activity? What do you do after your school? Any extra? Okay, like any art, craft, nothing? It's a good thing. It's a very good thing. It will keep you your mind in peace. Even if you play or you do exercise or anything, it's really good. Play badminton, do any sports. It doesn't mean you are wasting your time. Uh-huh. You are going for coaching. What coaching? Badminton coaching. Very good. So is this clear? Can so write down one homework here. Why you are closing everything? Just write one homework and tomorrow we'll discuss that out. Okay. I assumed that you guys must be knowing that, but anyway, I'll give you the homework. What is this? A concave mirror. Okay. What is this? Principal axis. Okay. This is your. See, this is small f means length of focal length. Okay. Small f means the distance between from this point to this point. Okay. That is small f. It's a distance. It's the measurement. Okay. And when we name this point, like you have a name, if we give name to this point, that is called focus F, capital F here. That's the only difference. Okay. So it, and the distance from here to here is called your F, small f. Okay. What I'm doing is I'm keeping an object here. No, not here. I'll keep it. This is C. I'll keep it here. Okay. This is the object. I want you to draw. Write out this. Just draw this. Put down this. This is your object. Let's name it A, B. Okay? A, B. You have done this? Atish. It's in the air. It's hanging in the air, right? The object. Okay. I want you to draw the image with incident angle, incident ray, reflected angle for this one. Okay. Yeah. Whatever the definitions are there, you use all the definitions and draw the image for this one, this object. Where it will form. Anyway, you know it's between C and F, so where it will form? Beyond C it will form, somewhere here. And it is smaller, so it will be a little enlarged. Okay. It is vertical, so it will be inverted. Okay. I want you to draw that. And I want you to draw the incident angle as well as reflected angle. Okay. Okay. Angle of reflection. All right. So that is your homework. Okay. Also, if V is if the image is forming, if the image distance is 90 centimeter from the pole, if the image distance is 90 centimeters from the pole, the focal length is 15 centimeter. Okay, find the object length and the magnification. Write it down. I'm giving you, okay, this is the previous problem. So in this problem, I'm giving you, and this is mirror formula, right? You know this. Don't forget, mirror formula is adding and lens formula will subtract it. Okay? I'll also give you the proof of that, but if that is just geometry. Okay, in mathematics, you will learn in circles. So I'm giving for this problem, I'm giving you V is equal to 60 centimeter. Okay, 90. All right. Sorry, 90 centimeter. F how much? 15 centimeter. You need to find U and magnification. These two you have to find, and you have to draw it, and you have to write the property of the image. Okay, so that will be your homework. So thank you very much. I hope you understood. Did you or not? You were sleeping in the entire class. I know. See, whenever I say anything, whenever if even if I'm wrong, just correct me. Like somehow I said the 90 and like just correct me out. Okay, so sometimes it happens that something is going on, so we tend to spell it wrong. Okay, but I'm saying each and everything, whatever I'm saying, teaching you in the class is very important. And with certain, I'm teaching you with certain assumptions that you guys have already finished these things. That's why I'm directly going to the problems. I've heard that you guys have problem. Mainly, you feel difficulty in problems, right? Theoretical part, you all are professionals. So, and I will also be forming some theoretical questions. Just go through the book once. If you have any doubts about light or reflection, anything, let me know. Let's discuss it and clear it out. Okay. So Atish, go have some crackers. Sanjay, don't laugh. Okay, so we'll end here. Yeah. Thank you very much. Yeah, it is.